today's lesson is going to be redox. It'll also be another video that I talk about, but right now we're going to talk about redox. And this is found in section 6.1 of your book. We are not going to do this entire section. We're just going to do one little part, the part that's entitled the photosynthetic process. We're only interested in learning about redox and these two terms. To start us off though, we're going to have a quick review of hydrogen. So if you recall, hydrogen is number 1 in the periodic chart. Therefore it has 1 proton and it has 1 electron. This has no neutrons. When it dissociates, as we saw with acids and bases, you will get a proton and an electron. That proton is the hydrogen ion that we talk about. So we get, basically when we dissociate, we get a hydrogen ion and an electron. This electron is no longer in the cloud, but because these have opposite charges, they'll still usually be in relatively close proximity to each other, and they will often travel together. So with that quick review, let's talk about these two terms. The two terms we're going to learn today are reduction and oxidation. This is where the term redox comes from. If you take the RED from reduction and the OX from oxidation, you get redox. These are often coupled equations or inverse equations of each other. So these will always work in conjunction with each other. So what is the definition of reduction? This is when a substance gains hydrogen ions and electrons. So remember, you can think of these two together. This is what is going to make up one hydrogen atom. So when a substance gains hydrogen ions and electrons, therefore the oxidation is the opposite of this. This one is when a substance loses hydrogen ions and electrons. Now sometimes this can be a little confusing because we just said reduction was gaining something. Well, there's also another definition involving these two, and it revolves around oxygen. And if something loses oxygen, it is reduced. Usually if you're losing oxygen, it's at the same time you're gaining hydrogen ions and electrons. So you don't need to worry about the oxygen. Just need to know the reduction is the gain and oxidation is the loss. And it's really nice that we have an acronym for this. And that acronym is OIL-RIG. Oil, oxidation, O is loss. There's our loss. Oxidation is loss. RIG, reduction. RIG is gain. Reduction is gain. So if you can remember those two, that mnemonic, you'll always remember which one of these is gaining hydrogen ions and electrons and which one is losing hydrogen ions and electrons. So let's take a look at this in an equation. And let's just look at photosynthesis. We'll also be looking at this when we talk about cellular respiration because that's just going to be the inverse. So in photosynthesis, we take 6 carbon dioxide molecules and 6 water molecules, and we create a single glucose molecule. So C6H12O6, this is a glucose. This is one of those monosaccharides we talked about. And we get 6 oxygen molecules. When we apply the terms of oxidation and reduction, we apply them to the reactants. So what do you notice about this equation? The only place we see carbon is in carbon dioxide and in glucose. The only difference in elements between the carbon dioxide and the glucose is glucose has hydrogen in it. So because carbon dioxide is going to gain hydrogen, the carbon dioxide, remember, reduction is gain, carbon dioxide is reduced. So where did that hydrogen come from? Well, the only thing in here that has hydrogen is water. So when the hydrogen leaves the water and becomes oxygen, it ends up being oxidized. So carbon dioxide is reduced. Put the R here. Water is oxidized. And I forgot to put a little D here. So water is oxidized to oxygen in this particular equation. So whatever substance gains is going to be reduced. Whatever substance loses the hydrogens is going to be oxidized. There are lots of equations we're going to be going back and forth on and talking about that with this semester. Another one that's going to be really important is going to be a molecule called NADH. So NADH is a molecule that's called an electron carrier. And we're going to need this when we start to talk more in depth about cellular respiration. When NADH dissociates, it becomes a molecule called NAD plus hydrogen ions plus electrons. So we started with a substance that had hydrogen and it lost it. And now we see the dissociation of those two. Here's the electron that this molecule was carrying. So if you lose in this particular equation, you notice the H goes away. So NADH is oxidized. It has lost hydrogen. You can go the other way too. We can build this molecule from these things. So this is what I said, that they go together. So NAD plus a hydrogen ion plus electrons can be built back into NADH. So now we see that the NAD has gained a hydrogen, so therefore it has been reduced. So NAD is reduced in this equation. So you notice, all we did was we went back the other way. Many chemical equations can go both directions. In this case, NADH is the reactant. These are the products when it is broken down, when it is catabolized. So this is catabolism, because we're breaking something down. Here we see the NADH is going to join with a hydrogen ion and electron, and we will build. So this is an anabolic reaction, because we build something. This is not hydrolysis, because water is not involved. This is not dehydration synthesis, because water is not also created. So here's where we use those general terms, anabolism and catabolism. With acids and bases, we can also see this process happening, because they also involve hydrogen ions. So when we had hydrochloric acid, HCl, and this would get broken down into hydrogen ions and chloride ions. In this case, the electron is going to get put on here, which is why we have the negative, but you can see we've lost hydrogen from our original substance. So in this case, because we've lost, in a sense, this has also been oxidized. So that is oxidation and reduction. Make sure we get those two terms down, because we will be using them a lot when we talk about cellular respiration.